starting with Danique, so being a veterinarian and having worked with geriatric animals specifically, are there particular things to pay attention with regard to how you can take care of these animals such that the things like dosing that we normally have to worry about, are they a bigger problem in geriatric animals? Are you more limited in what you can necessarily give them? And is it enough of a stress that it's potentially impacting the efficacy of a given intervention?
It's definitely something to consider as you're doing your study designs. So we do often talk about how these animals can be frail and can be sensitive to stress. That being said, they're also remarkably robust little dudes. So it's something you want to consider. So can you choose alternative? This is all reduction, refinement, replacement, right? Ethical considerations. Can we choose interventions that might be less stressful in terms of, yes, we're providing a treatment in the food rather than having to do oral gavage daily, which would be a lot on a young animal, let alone an aged animal.
And a lot on the staff.
And a lot on the staff. No one can sit, don't worry about the staff. So absolutely there are some practical considerations to consider there. But to the point of the staff, I think if you have those individuals who, again, know how to work with those animals in such a way that they can recognize if that animal's starting to show a little bit of an additional sign of stress due to restraint or something like that, and give that animal a break if needed prior to doing that next dose, then there's still actually quite a ways of being able to administer substances to these animals on a relatively frequent basis that can be safe for them.
Maybe I can just add that I think one of the challenges we have with older animals is anesthesia. And so they don't respond typically well to anesthesia. And so when you consider different frailty indices, we like the 31.1 that Susan Hallett developed, even though it's not as quantitative. It's much less invasive and it doesn't require the anesthesia. If you want to go in and look at, echo and bone density and DEXA and all these things, those are great, but when you're doing a lifespan experiment, you're actually can impact the aging of the animal using a lot of anesthesia, so I think that's something to be cautioned there about.
And I think an interesting actually development of the LEV study that Aubrey came up with in terms of also having the mock and the no controls. So again, by the end of the study, we'll have an obscene amount of data that we can also then parse through and see what sort of an effect the treatment itself might actually have had on the animals.
Well, what I'm curious about actually is how much of it do you think is psychological stress versus physical stress? So say the handling, the frequency with which you're poking them with things or going in and physically taking them out of the cage, is it psychologically or emotionally stressful for them versus just having a certain volume of fluid that's going into their stomach? Because there's a lot of interesting work happening in things like mind-altering drugs that people are looking at starting to for longevity purposes, and if it's something that might improve their sociability within the cage or their overall perceptions of stress. Do you think that might play a difference?
It absolutely could, and for the staff and the animals, actually. But again, I think they're inherently prey animals. So we do what we can in terms of working with them and being able to acclimate them to the sorts of procedures that they're going to be doing. Again, they essentially don't really know life outside of a box, so we make it as comfortable for them as we can. But compared to the larger species, where you can really work with them and train with them, mice inherently, again, will only do so much because they are that much of a prey animal. But again, it's something that we can evaluate in the studies as we see how that works out with what actually was due to handling versus actual interventions.
Yeah, I think another factor we didn't discuss is temperature. We often keep these vivariums at temperatures that are not optimal for mice, and I worry somewhat that that's affecting the aging outcomes that we're seeing. It's not an easy problem to solve, but we keep the vivarium at human comfortable temperatures, not mice comfortable temperatures.
Do you have, yeah. Oh, well, a related thing that Aubrey and I have been discussing in some detail is the possibility of including smart cages in one way or another, so something that might be temperature controlled, or it might be a video assessment or AI algorithms that can interpret if they are behaving in a more frail fashion. Now, these things, because of the technical setup required and the actual equipment and everything you have to buy, it would be probably considerable investment. And so the question is do you think it's enough of a benefit to remove the, say, handling component to have them in their natural environment? So like home cage monitoring, you're not putting them in a stressful situation, but is it worth it?
That's a very good question. It wouldn't be my investment there probably for those cages. So that's up to you guys, of course. I think it'd be a good question. It would be interesting to see what could come out of that, because I think that, you know, having worked with these aged animals for 10 years or other people for however long as well, I think we've been able to adapt procedures quite well where these animals can tolerate quite a lot and in a safe, not super stressful manner. So it would be an interesting comparison that could actually possibly yield quite an interesting result.
I mean, we're thinking about trying to pilot with one of those just to compare notes.
There you go. Let us know.
And so Aubrey very briefly mentioned that we are looking for collaborators for data crunching and looking for trends in pathology data and some of our blood work, things like that. What we have lifespan, or mean and max, as one of the outcomes we're looking at. What other insights do you think might there be in tissues, in data that can be assayed? What kinds of things?
Yeah, I mean, honestly, the sky's the limit here. I think the main reason why it's so valuable to us to be working with the entire community in this area is that pretty much everything that you might want to hypothesize, any hypothesis you might want to test, whether it's us testing it or whether it's anyone else testing it, you know, you can gain it from mouse experiments, mouse lifespan experiments. Very much agree with Brian's point towards the end of his talk that, you know, naturally aged mice are potentially quite informative, perhaps more informative for human health, human medical research than mouse models of disease. And so, you know, the sky's the limit, really. There's so many different things. You know, someone of the questioners earlier mentioned, you know, in determining cause of death. You know, we definitely want to know as much as we can about cause of death, and some of that can be determined by crude pathology that we do when the mice die. Some of it can be done by, you know, anatomical analysis of tissues. Some of it will be at the molecular level. It's, you know, really, you could go on forever thinking of the number of ways things we could find out from these studies in this way. And that, of course, again, makes me very happy that we were able to pull off such a study that's very expensive but extraordinarily good value for money.
And I think one of the things we can do, and to some extent you can do as well, is by harvesting tissues, we can tailor experiments to collaborate with people to look at specific issues that they're interested in. So one of the reasons we chose to do this is we could get way more molecular by looking at harvesting the animals at a certain time point. It also allows us to specify the experiment in a way to work with collaborators, and we're also happy to work with you guys and any other collaborators out there that that are interested in interventions that might affect longevity.
Well, so if these interventions, if combinations are successful, the animals might live a very long time. So it will potentially be a very long time before we actually get the results from the study. Is there a way that we can get insight along the way to speed things along, because these things already take a very long time and we are all in kind of a hurry?
Yeah, I mean, of course, the possibility always exists to do preliminary analysis, you know, just, for example, comparing baseline measurements of things with measurements at the first cull point. And, you know, perhaps it would be quite surprising if any particular measure actually got to reach statistical significance that early on, but will sure as hell be, you know, taking every opportunity to ask such questions. I think, you know, at the end of the day, the longest-lived mice are going to be the most interesting ones, and therefore the ones that we want to do the most intensive analysis on to find out, you know, how we succeeded. But then again, conversely, if a certain treatment group dies unusually early, you know, that's also really fascinating. We might want to find out, for example, whether the combination of two particular interventions actually is bad for the mice, even though the individual interventions are both good. That's the kind of thing that an experiment like this can discover.
Yeah, I would add that, there's a lot of movement both in mouse studies and in starting to be in human clinical trials that we need to all get together and decide the one way to do an experiment. And I think that's a mistake, because if you think of it, there's an exploration space you can be in doing research. Now, if everybody's doing completely different things, the disadvantage of that is it's hard to compare one to the next, so that's a problem. But if everybody's doing the same thing, you're only exploring a narrow little wedge of that exploration space. So I think it's still better in both mice and especially in humans to have different approaches being taken, hopefully aligned enough that we can compare outcomes, but at the same time not so restricted that we're all looking at the same thing. I don't think the field has matured to a point where we know exactly what we should be looking at. And well-designed experiments that have overlapping features but differences could be much more valuable in the long run.
Here, couldn't agree more.
And so, Danique, I presume it is too early to share have you noticed anything in differences between any of our different groups?
It is indeed still pretty darn early, so sorry. Otherwise, I was going to let Aubrey do that, if you want to give any insights already. But again, we're just evaluating things. We'll see as things continue to go, and Aubrey gets to be the filter for that. And when he gets to surprise the community on those results, that'll be up to him.
Yeah, I've been starting to put out interim data on survival, and we'll do some on the longitudinal analysis. But every single thing I put out on social media to do with that is laced with repetitions of the phrase, "This means nothing yet."
What do you think about the influence of the strain that we choose of mice on the results that we're getting, or the impact of their genetics on, say, small molecule specificity?
Yeah, let me start on that one. So this is another of these trade-offs, very similar to the one that Brian just mentioned, actually, that, there's one particular inbred strain, C57 Black 6, which has been used for the large majority of mouse lifespan studies throughout now since the dawn of time, and therefore there is an advantage in continuing to use that strain for comparison with other people's work, but equally there's a disadvantage that, there are things that that different strains have that are perhaps going to diminish how much we can learn. And of course, these days, the strain du jour that people are quite excited about is the one that the intervention testing program uses, HET3. The intervention testing program overwhelmingly does interventions starting relatively early in life, and perhaps as a result of that, it's taken until now for the main suppliers, such as Jackson Labs, to have reasonable numbers of pre-aged HET3s for use in experiments like this. We're actually monitoring that right now in relation to RMR2. As I mentioned in my talk, we don't know when we're going to be able to start RMR2. That depends on how quickly people write us large checks. But we definitely are considering the possibility of doing RMR2 with HET3 instead of Black 6.
And so, Brian, you talked, I think, in one of your previous talks when you went more into alpha-ketoglutarate, you spent some more time talking about how the effect size is much greater if you're biologically, say, older to begin with. Is that the same type of aging intervention or, say, damage repair as something that is also going to have an effect size significant enough in somebody who is, say, their biological optimal?
Yeah, I think it's a question we don't have the answer to right now, especially, and it's going to potentially depend on the intervention as well. It's funny, when I show that AKG result, everybody says, oh, that's exactly what I expected. I didn't expect that necessarily, because a lot of exercise maniacs take AKG, so it was possible that the people that are exercising would benefit more from the intervention as well. And we don't know whether this effect with AKG we're seeing is extendable to other interventions yet. Some of them may affect people that are already optimized more and not affect people that are not doing things to optimize. So I think it's still an open question. Another open question is whether the current interventions are going to square the curve or actually extend maximum lifespan. Again, both both outcomes are a huge benefit to medicine, but they mean different things. And some of the work that, like Peter Fedichev's done looking at large-scale data, suggests that the interventions may be more, that we're testing now in humans, may be more squaring the curve. Now, having said that, many of them do extend maximum lifespan in mice. So I think what you're doing is highlighting a very open question right now. The AKG had a bigger effect on health span than lifespan, even in mice. So perhaps it's not that surprising that that's what we see in humans. And some other interventions have equal effects on both. So we just need more human testing to answer that question, I think. So.
What kind of effect size do you think that we need in order for, say, the rhetorical aspect to hit with people? So I think Matt yesterday said, we don't want to see mice go from 800 days to 1,000. We want to see the baseline, as you both pointed out, to be high enough. And then is it 1,400? Is it 1,600 in humans? Is it 6 months? Is it a year? Is it 2? Like, when do we think, okay, we are at least moving things forward right now?
Yeah, I think in humans, it's a really hard question to answer. And so one of the things that we're considering in the clinical studies with Andrea is taking people that are biologically at or older than their chronologic age as an inclusion criteria. In fact, we're doing that with AKG. Whether we do that with other things is still unclear. But, you could, in other words, take subpopulations of humans and test them specifically with interventions. You could take people that are already biologically optimized for age, if you believe in these clocks, and then take those people and study them to see if you can push the limit even more. That would be an interesting study. I think right now the most important thing is to get outcomes for these interventions in humans that show that some of the things that are being shown in mice are at least translatable. I think that will increase the public awareness and excitement if we can show that. So, and it may be that choosing the people that are already optimized is setting the bar as high as possible to achieve outcomes. And ultimately that may be the thing to do, but right now I'm not so sure.
What, in terms of the study designs that we, for rodent studies, so not necessarily messaging, not necessarily policy, what else do we need to see, or what should people be working towards? What are we missing still,
I think
if anything?
Yeah, I think we're definitely, any experimental system has limitations. If I want to highlight one limitation that exists in mouse studies, which I think is important both scientifically and rhetorically, it is that mice are, well, I'd love to be doing more experiment on rats. Rats have a bunch of advantages. By virtue of being bigger, there are things you can do. There are just practical things you can do. But also they're smarter. You can do more cognitive experiments. These are things which I think could potentially allow the experiment to be more valuable. But unfortunately, rats have this irritating feature that they're a lot larger than mice, and you just can't get you can't get 1,000 of these things into. Right? I have no idea. How many rats do you think you could actually fit into the facility at capacity?
Well, the benefit that we've set up at ICOR is actually that we've established a facility where we have a lot of auxiliary spaces for some of our bespoke other equipment and facilities that we use right now. So we could increase capacity absolutely if needed if we decided to use rats, because I do like rats a lot actually. But they very much are larger, and very much we do, depending on the strain you use, see the pancake version of a rat that can turn out, where you really, by the end of it, would end up with almost needing single housing just based on those weight sizes. So I think that really would be your limitation, not only from the social stress aspect, as we've possibly talked about a little bit, but really, honestly, probably just that you then end up with needing 1,000 cages, possibly, if you're looking at doing your 1,000 animal, rat study too.
Anything, Brian?
No, I would just, I answer a question you didn't ask, or maybe it relates, but I just want to reinforce what Matt said yesterday, I believe he said anyway, which is that we've really only explored a tiny area of the intervention space, and not just with drugs and natural products, but as gene therapy comes online, stem cells, there's a wide range of potential interventions, different kinds of rejuvenation therapies that could have very dramatic effects on lifespan. And we need to keep our minds open to looking how can we expand the exploration space. So I like the idea that you're doing a gene therapy approach. I think that we need to be thinking more broadly than just small molecules, and also different classes of small molecules. So.
Yeah, thank you. So I'm afraid we're going to have to draw this to a close. We're obviously run way over time, and I hope you all think it was worth it. But anyway, please go and grab yourself a coffee and come back here as quickly as possible. I'd like to try and start again in about 5 minutes.
10 minutes, not 15, please. Thank you.